everybody, welcome back to another episode of this new classroom. Today we're going to be taking a look at the floor framing and just kind of quickly highlight some of the different parts of the floor frame, how they all work together, just to have a little bit better understanding of how the floor system actually works. To help explain this, I've made a little mock-up representing a foundation. So here the edge of the board represents the foundation wall. Here this little black layer, that represents our foam gasket. Basically it is just a 1/8 inch piece of foam. You roll that out. There's a couple reasons we want to use that foam gasket. Number one, you do not want any wood to be coming in direct contact with the concrete because there could be moisture in the concrete, which then could end up in the wood, causing that to rot out. Also, the top of the foundation wall is never going to be perfectly flat. There's going to be little voids and dips and bumps. What that foam does is help to seal off any little potential air gaps, preventing air from moving in through that building, and that's going to then reduce the overall efficiency of that building. So something as simple as $10 worth of this foam gasket could save thousands of dollars in heating cost over the life of that home. The sill is then going to be attached to the foundation. In this example, I just have them nailed down, but you're actually going to stick anchor bolts into the concrete before it's fully cured, and then I can use those anchor bolts to fasten the sill to my foundation. What the sill does is allows me to have a mechanical connection between the foundation and my floor structure. If we're using traditional framing methods, we're going to want to use a girder. There are different types of girders, but you're typically going to see a build-up girder, which consists of 3 different beams all nailed together. Again, you could use a steel beam. There's a bunch of different options to use. But what a girder does is basically it is a load-bearing framing member that is located somewhere in the middle of that building. You're very rarely going to be able to find a framing member that is going to be able to extend from one end of the building to the other. And even if you do, there's going to be a lot of deflection in that, so it's going to have a tendency to sag towards the middle. By putting that girder there, even if you do have that running full length, that's going to hold that where it's at, and I don't have to worry about any beam deflection. The girder itself is going to be supported by a post or a column. There's different materials you can use to support that as well. Without that support post in there, that girder could still sag a little bit depending on the weight load that's put on there. So now we're going to start putting out our floor joists. We have a joist header which is going to be found at both ends of the building, running the entire length of that structure. And then we have the floor joists that run from one joist header to the opposite joist header. In this example, you can see that my floor joists do not run the entire length, so they're just running a little bit beyond my girder. You can also notice that I have some blocking in between each of the joists. Those need to be in every 8-foot increment. A couple things that blocking does, that helps tie everything together. So if I have a concentrated weight load on one joist, that helps to spread that out over the greater area. If you look at the blocking, you notice that they are staggered. We do that just for the ease of installation. By staggering them, I'm able to run my fasteners through the edge of my joist, and then when I put the next one in, I'm still able to fasten that, and then I just keep offset. Just makes installation a lot easier. So we'll fast forward to the completion of this structure. We have the floor joists coming from the opposite end, and they are overlapping on the girder. If everything is laid out correctly, the two joists will be in alignment and they can get fastened together and then fastened down to my girder. And then the last step is to put the subflooring on there. Typically going to be 4 by 8 sheets of at least 3/4 inch plywood. And if you can see on there, the seams are going to be staggered. That's going to allow for a little bit more strength when I go to assemble everything, put it all together. Subfloor gives me now a stable surface to work on, so when I go to build the walls, they get built right on the subfloor, and then that gives me something to put my actual finished flooring down, if it's carpet, tile, hardwood, whatever it is. When you put the subfloor down, it is typically going to be glued and screwed. If you don't put glue on there, the fastener could give way over time. If you use screws instead of nails, the screws will hold that down tight to the floor joist. It is also important that any of my seams are supported by a joist. If that seam does not have a joist below it and I step on that, it's going to move independently, and that could also cause a squeak in the floor. You might run into a situation where a joist hanger needs to be used. This is an example of a metal joist hanger. It gets nailed on to the joist head or rim joist, whatever you want to call it. And then the joist itself will actually sit right in there. And then you actually would fasten those in through the joist into the header as well. You might run into a situation where I maybe have a cantilever. And a cantilever is going to be where I have a framing member extending beyond my support. In this case, we would want to have a joist hanger upside down, so when I put a weight load on that, remember nothing is supported at this end, I put that weight load on there, that hanger prevents that from tipping down. Thanks for tuning in to another episode. Hopefully you have a better understanding of how the floor framing works, and we'll catch you on the next one.